Welcome to our tutorial focusing on NATO simulation interoperability. NATO conducts many simulation-based computer-assisted exercises. These exercises can become very large, and the challenge is to ensure the interoperability of all systems. In the past and until today, the preparation of these exercises cost a lot of resources like time and technicians and computer specialists, which also translates into a lot of money. To save on these resources, NATO established our group, the MSG 163, to find a solution for reducing the integration time of these systems in exercises. The group came up with an idea to certify the capabilities of all systems before they join the exercises. Now, the group has successfully created a free and open source tool that can be used by developers and users equally. The tool can even be used as an acceptance tool between industry and customer. My name is Horst Behne. I'm the branch head of the Modeling Simulation Coordination Office with the German Armed Forces. I'm also the co-chair of the NATO Modeling and Simulation Research Task Group, MSG 163, Evolution of NATO Standards for Federated Simulation. This morning we will guide you through 3 topics currently addressed by NATO with respect to simulation interoperability certification, tools and standards for federated simulation. With me today, I have 3 experts who will go into further details of these topics. Mr. Reinhard Herzog, he's a senior systems architect and developer at Fraunhofer Institute of Optronics System Technologies and Image Exploitation. Then Lieutenant Colonel Tobias Kuhn, he's the branch chief of the Modeling and Simulation branch with the Modeling and Simulation Center of Excellence in Rome, Italy. And Mr. Björn Löfstrand, he's a senior systems architect with Pitch Technologies in Sweden. Before diving into details, I will give you a short overview and an introduction to the topics. First, Björn will present the current work on FOM modules and developed by NATO. Then Tobias will present the concept related to the NATO HLA certification process. And last but not least, Reinhard will present the tool developed by NATO to support these processes. You might not have expected, but NATO does have an M&S master plan. Its strategic vision is to exploit M&S to its full potential across NATO and the NATO nations to enhance both operational and cost effectiveness, and it comprises of 5 main objectives. To establish a common technical framework, to provide coordination, common services, to develop models and simulations, to employ simulations, and to incorporate technological advantages. An implementation plan to meet these objectives is in place, and the work we present today is mainly related to objectives number 1 and 2. The NATO Modeling Simulation Group, or short NMSG, is a working group with the NATO Science and Technology Organization. NMSG performs M&S research and development of NATO standards to promote cooperation and interoperability among alliance bodies, NATO member nations, and partner nations to maximize the effective utilization of M&S. NMSG is officially nominated as the delegated tasking authority for NATO M&S standardization since 2003. NMSG also has the technical cooperation agreement with SISO since 2007. An updated agreement was signed during the recent IETSEC 2019 conference here in Orlando. NMSG task groups have also provided significant input to SISO standards developed over the years. For example, NMSG provided significant input on the modularization of the RPR FOM version 2.0, and other task groups have provided significant input on CBML, MSDL, and UCAT SISO standards. NATO is also a user of several SISO-developed standards, including the IEEE 1516, which is the HLA standards, and the Distributed Simulation Engineering and Execution Process, DSEEP. SISO and NATO standards have successfully been applied by alliance and partners in federated simulations to support education, training, exercise, and evaluation. NATO Standard 4603 mandates compliance with the following. Participating nations agree that procurement and new development of simulation systems are compliant with the latest version of IEEE 1516. Participating nations agree to utilize the HLA compliance certification process established by NATO Modeling and Simulation Group. The Standard 4603 has been ratified by approximately 20 nations, NATO nations, is supervised by NMSG and is under custodianship of the US DoD M&S Coordination Office. On a regular basis, NATO and partner nations use distributed simulation based on HLA and related standards such as SISO RPR FOM 2.0. There is a continued need for NATO to experiment with, update, and further evolve NATO standards for federated simulation to meet new and evolving simulation interoperability requirements, and to harmonize with new and evolving SISO standards. In order to better support NATO computer-assisted exercises and other simulation-based events, the NATO Allied Command Transformation, ACT, initiated the NATO Education and Training Network, or short the NETN, program in 2007. Several NMSG research task groups have supported the development of FOM modules that extend and complement the SISO RPR FOM. The Allied Modeling and Simulation publication, AMSP, titled NATO Education and Training Network Federation Architecture and FOM Design, NETN FAFD, is a set of modules addressing aspects of shared data in distributed simulation based on HLA. AMSP 04 Edition A was published in March 2018, covered by NATO Standard 4800, and defines the NATO FOM modules and associated documentation. Integration of distributed simulations and tools into interoperable federations of systems is a complex and time-consuming task. It requires extensive testing of individual components, interfaces, and an integration solution. To support this task, NATO M&S relies on a common technical framework based on standards like the high-level architecture, the HLA standard. For compliance with the Standard 4603, NATO Modeling Simulation Group has also established a service for simulation interoperability certification, including the development of an integration verification and certification tool, short IVCT. I would like to hand over to Björn for a more detailed look into the NETN FOM.
So as was mentioned, and as you saw in the slides, there are lots of abbreviations, of course, and we try to tackle some of them in this introductory section of this tutorial, and I will go through some more. However, the tutorial is based on the assumption that you know a little bit about distributed simulation, that you know about the existence of HLA and FOM design and FOM modules. But if you have any questions after my section of the tutorial, we'll have a short question and answers session, a short break, and then we'll continue with the certification process. A lot of different abbreviations. NETN is a core abbreviation here, the NATO Education and Training Network. STANREC and STANAGs are the NATO way of referencing standards as a recommendation or a standard agreement. So it's a covering letter indicating standards. In this case, STANAG 4603 is pointing to the HLA standard. STANREC 4800 is pointing at another reference FOM modules that we will discuss now, and some other terminology that I will address during my presentation. The NATO Education and Training Network, as Horst mentioned, was established in mid-2000 or 2007 approximately timeframe. It was an initiative by the Allied Command Transformation, the NATO Allied Command Transformation in Norfolk. And they tasked the Science and Technology Organization in NATO to start a task group to look at delivering standards and delivering concepts related to this vision. In order to deliver NATO and partners, so NATO is not just the NATO nations, it's a whole bunch of partner nations, a persistent, distributed, joint training capability that leverages existing national expertise and systems. So it's all about leveraging what is already there in the nations, the investments made by different nations in the best possible way in order for the nations to come together, to do exercises together, to train together. So this vision, even though the program changed its names like 3 or 4 times over the years, the vision has remained the same. And this is the vision that drove the first iterations of the standards that we're going to discuss today. So the education and training network concept is still alive, and it's something that we focus our attention on when developing standards for federated simulation. However, it consists of several different parts. So one part is guidance in how to develop computer-assisted exercises for NATO and partner nations. So it's more process-oriented, best practices guides, standards profiles, to help you in the development of distributed federated simulations and support exercises. Another part are focusing on the federated distributed simulation standards, and this is going to be our focus here today. And the third part had to do with connecting all the nations' assets together in a distributed federated mission training network. So we will focus our attention on one specific standard during this part of the tutorial. It's the AMSP04, the Allied Modeling and Simulation Publication. So this is the abbreviation AMSP number 4. And the full name is the NETN Federation Architecture and FOM Design, or NETN FAFD. So I will sometimes use these abbreviations. So if you forget about this, you can ask questions, but these are the terminology that we are using. The NETN FOM, the NATO Education Training Network FOM, Federation Object Model, contains the modules that we will be presenting here, which are extensions and complements to the Reaper FOM. I will not address the 2 other portions here, the Federated Training Network or the CAC's M&S guidance. So the federation agreements that we are building in this AMSP04 requirements has been driven by the NATO nations and partner nations throughout a number of different task groups. MSG 68, 106, 134, 163. So it's a whole series of task groups that have been working on this, bringing national expertise together, looking at what their current approaches are in designing federated distributed simulations, bringing all that together and harmonizing the different approaches to come up with a NATO standard way of representing information to be shared in a federated distributed simulation. So we received a lot of input from different nations, from some of the major programs that develop federated distributed simulation, and the resulting object models that we're going to show you have been used in different exercises by the partner nations. Big exercises, and it's really being used, and we get feedback on these modules, and we continuously improve the modules. So NATO has pointed at the AMSP04 as a recommended standard to use. It's not a mandated standard right now, it's a recommendation. It's a STANREC, not a STANAG. And it's been used in many different contexts, but primarily for computer-assisted exercises to support training. But many of the modules are more general in nature and can be used for other purposes as well. So this is a short timeline. So the first version of this federated object model, the FOM, was actually released in 2010. And we've continuously worked on this, and every 4 years we have had an update. So in 2014, we had the version 2.0, and we released that in 2018, and now we're looking at a version 3 for 2021. We're going to deliver a draft version in 2020, end of the year, and we'll go through the approval process by the NATO Standards Organization, and hopefully be released early 2021. So there are several different versions of this, and of course it's a modular FOM, so it contains different modules which also have different versions. So it's a kind of complex configuration management task to handle all this, but I will discuss that a little bit as well. So there's a series of versions, but what I'm presenting today is the version 3.0. So it's a modular FOM, and is a part of this FFD, Federation Architecture and FOM Design document, which is basically the federation agreements associated with FOM modules. It consists of a number of modules that also have dependencies with each other and with Reaper FOM to some extent. The FOM itself is maintained and updated by the NATO Modeling and Simulation Group, and specifically the subgroup called the MS3, the Modeling Simulation Standards subgroup. And currently, the development of the version 3 is delegated to MSG 163, which is the task group that is represented here by the presenters. And we continue our work until the end of this year, and after that, there will probably be some new task group being tasked with maintaining these object models. This is the current version that was released in March 2018. We will not focus on this version. This is all available. So all the modules are not classified. They are all available over the internet. They are all documented and available for you for download, the documentation and the FOM modules themselves. Everything is on GitHub. I'll provide you the link at the end. But our focus for today's tutorial are the next version, so version 3. But I just want to give you a short introduction to the current version that was released in March 2018. So it basically depends on some of the Reaper modules, not all of them, and extends some of those to introduce additional capabilities of exchanging information between simulations in the areas of logistics, CBRN, aggregate representation of units, some general FOM modules for supporting aggregation, deaggregation, and transfer of modeling responsibilities, and a couple of modules supporting simulation to C2 interoperability. So these were all defined, and the requirements associated to this were all derived from discussions from the different nations in these different task groups over the years. And the solution provided by the nation is implemented in these modules. And it's been used by various systems and in various federations to support various activities. Primarily training in computer-assisted exercises, but also for other purposes. We received, of course, a lot of feedback, and we have tried to harmonize the different modules to ensure that we have a sound foundation and architecture for the modules. We actually merged some of the modules for logistics, and we also introduced some new modules that has been high on the agenda for the different nations to be able to support. We still have representation of aggregate units and the CBRN and extensions of the physical representation of platforms, but we also include new modules such as the representation of weather and weather effects. We have also representation of AIS traffic, civil ship traffic, and a module for controlling tasking of CGF entities, the entity tasking and reporting, and also a separate module for representation of organizational relationships, and allocation of initial information to the simulations. So I'll go through some of these. And you might wonder why these modules? We have different experts from different organizations, different nations coming with their needs. We try to find a balance what we are focusing on. There are, of course, many other areas that we have received input on, but we are not managing to put into version 3. So these are the ones that we can complete and do some testing with before releasing the standard. So we have a lot of other modules in development and under discussion, and it may also be some modules that I don't present to you today that will be included in version 3 that I'm not exposing here today. So basically a modular approach. So during this 30 minutes or so, I will go through some of those modules in a little bit more detail. Some I will just touch superficially, some I will explain in more detail. But as I said, all the information is going to be available or is available already for you to download, for you to read online. So I'll provide you with the links as well. One of the core modules that we are developing or have been developing is a representation of organizational relationships. And the primary standard that we're basing this on is the MSDL, the SIW standard 7 from 2008, the military scenario definition language MSDL. There are some additions that we sort of introduced in order to represent some of the things that we need in order to allocate modeling responsibility to different federates. But it basically covers force relationships, initial setting and values for the different simulators. And it's used for a couple of different purposes. One is for initialization of a scenario. So we're using the representation of the task organization as a way of initializing the simulators, but we also use it to represent the dynamic changes of the task organization during execution. So you can create temporary units or change the subordinate units to belong to some other unit dynamically during execution, and it will be reflected across the federation. We also add in this the capability of uniquely identifying units with a UUID, which has been proven to be very useful in order to describe scenarios and to be able to rerun the execution and still be able to collect and reference material from the different runs instead of auto-generate IDs for all the units. I'll just show you a short example of a design that we tested where we're using MSDL files. So MSDL defines a schema for an XML file, which captures the force structure, the force relationships, and also we added the possibility of adding initial allocation of modeling responsibilities to different federates. So we use it for initialization. So we have components that reads the MSDL file, publishes objects and interactions in the federation that represents the organization, and represents changes in the organization. And we also have tools that can manipulate the force structure in runtime. So we can change through the XCON systems the force structure to create a dynamic or order battle or force structure. We also have CGFs that implement the support for this, subscribing to these object classes in order to receive that information for initialization. So they will discover which units they will represent, and also initial values for setting the initial state of the units. And we have systems that can capture changes in the order of battle and create snapshots, also in MSDL file format, in order for reinitialization. So this FOM module is a sort of mapping between the MSDL standard and a representation in runtime of the organization in the federation. This is just a short description of the major parts in the object model that represents the organization. So we have units. So the units has a lot of information about holdings, also of course about their initial state. And there is also a separate class for representing force relationships. So in major exercises, you often have a very complex relationship between different forces, and sometimes even asymmetrical. So force A is friend with force B and force B with force C, but force A is not friend with force C. And this changes dynamically during major exercises. So the way a force relates to another force may change during the execution of a computer-assisted exercise. So that's why we also represent the force as an object, so we can change that dynamically, and it will be reflected to all the participating simulation systems. We also have a way of representing the initial allocation of modeling responsibilities. So we register for each federate, for each simulation. We can indicate which units will belong to that federate. What federate will have the responsibility of modeling that specific unit. One of the key attributes here is the universally unique identifier. So in ReperFOM, we have one way of identifying platforms and aggregate entities, and it's based on site application and auto-generated number counter. This makes it very difficult to compare different runs of the execution because that number may change. There's also other ways of uniquely identifying units by marking or call sign and things like that. but sometimes that is not guaranteed to be unique. So in MSDL, as well as in this representation, we are using a universally unique identifier to reference objects. And this is also not only in this FOM module, but also in the extension of the reperform aggregate and physical entities. So we're introducing a new attribute called the universally unique identifier in order for us to reference those objects. And the way we are doing that is by extending the existing object classes in the Reaper for the representation of aggregate and physical entities, and I'll show you that. And that has some relationship to what's going on in HLA4, which I will mention as well. So the NETN organization published the MSDL in the Federation, dynamically change it, use it for initialization and for creating snapshots for reinitialization. That's the main purpose of this. So the second, or the two second modules I'll introduce are the extension of the reperform aggregate and physical entity representations. So in the reperform, you have representation of aggregate entities. Actually, in the reperform, that aggregation could be anything. But in our interpretation and our extensions, it's units. It's a battalion or a brigade or a company. They're not physical things, but they are units. And the reperform also has a representation of the platforms, the physical entities, equipment, platforms, vehicles, and we also have an extension to that as well. Primarily to include the possibility to reference using the universally unique identifier, but also with some additional attributes. So for the extension of the reperform NETN aggregate entity, we have an object class called NETN aggregate. It consists of some additional attributes that are not in the reperform, but what I wanted to highlight here is the universally unique identifier. So this points back to that unit that was defined in the MSDL file. Even if you don't publish and use the NETN org FOM module, it still can be valuable to reference the MSDL unique identifier. So you don't have to publish all the NETN org objects in the Federation, but you can still use the identifier to point at the scenario unique identifier. And for the NETN physical, which may be a little bit hard to read here, we also do an extension. So it's a subclass of the reperform classes where we add some additional attributes and the unique identifier. And based on the FOM merging rules in HLA and the rules of HLA, we cannot add attributes on existing classes currently. So that forced us to create subclasses for each of the different leaf nodes of the platform, which is not the best design, but this is also something that we know will be solved with HLA4, which will allow to add attributes on existing object classes. But that's something that we'll address in version 4 of the NETN FOM. So right now, as you can see, there's subclasses for each of the different platform types, and they all have the same attributes defined. And this is because we were not allowed to put the attributes on a higher level. There are also extensions on cultural features and munitions, which has a little bit different set of attributes, but still have a unique identifier, so we can use that to reference uniquely between the representation of the object in the Federation and the scenario file. The next module is logistics. So based on feedback from the nations, we identified a need to both simplify, but also to extend some of the reperform representation of the logistics operations. And we're talking about federated logistics operations. So if you have two simulators where you need to somehow coordinate how they are modeling, for instance, a transport. So one unit simulated in one simulator needs to be transported using some platform in another simulator to provide repairs and to transfer supplies. For instance, for air refueling from one federate representing the refueling platform and another simulator representing another platform, how do you transfer this in a coordinated manner in a federated simulation? Transport of supplies between facilities, moving things around on the battlefield, refueling depots, refueling and resupplying different bases and so forth. And also repair during the execution. So we have models that provide information on how long it takes to repair material and platforms. And of course, transport of units and platforms and humans by different means of transport. If you model this in different simulations, you will need to be able to have a good pattern to represent how this is done. Even in the version 1.0 of the NETN, we developed this. And it's based on a service request, service offer, service acceptance pattern. So one simulator requests some type of service, transport service, or a refueling or a resupply. And it's offered, so there's a negotiation phase, and you accept that offer. And then when you're ready to receive the service is started and the transfer is actually taking place, transfer or the transport. And then you have an acceptance phase where you're sort of concluding this transaction. So in the left side is a simplified picture. On the right side is a more detailed description, which is available in the documentation with different exceptions and different variations of this pattern. But the basic process is you request something, you get an offer from another simulator to perform this modeling, and then you accept that offer, and then it's conducted, and then you have a finalization. So it's based on a number of interactions. So there is the FOM module consists of a root interaction class and a number of subclasses to capture all the interactions between the federates in order to support the pattern that we saw in the previous slide. So you request something, you offer something, you accept the offer, you have indications of when the service started, and if you cancel the service, you'll have interactions for that and the way of handling cancellation of the service before starting delivering it or during delivery. And you can also cause reject offers and so forth. So these are the interactions that we use in order to model that pattern for negotiation, delivery, and acceptance of this type of logistics operations. So transfer of resources, repairs, transport of units and equipment. The next one is the transfer modeling responsibilities. You may know that in HLA we do have ownership management services, so we can transfer responsibility of modeling individual attributes from one simulation to another. So there is some built-in support in HLA. However, it's hard to coordinate and make sure that those acquisitions of modeling responsibilities or divestiture gets to the right federate. So in HLA, you're not aware of the other federates, you're just aware of the federation. In our case, for our use cases, we really needed to make sure that the transfer was made from my simulation system to a specific other simulation system. The transfer modeling responsibility is a combination of the interactions and the HLA object ownership management services, and it can be used for several different purposes. You can transfer responsibility from a live simulation to a virtual or constructive simulation. So if you have live players that will stop playing live, you can bring them into a virtual or a constructive simulation. Vice versa is harder. Go from a virtual or constructive to live, especially initialization. It's a bit tricky to get into the right location at the right time. We can also, of course, transfer between virtual and constructive. So go back from a virtual to a constructive and then saying, for instance, I want to play this specific unit in the constructive as a virtual and associated with some virtual simulator. So you do that dynamically during execution. So you can change modeling responsibility between the different simulators, between the different types of simulators. Transfer between high and low fidelity models, and also transfer to support other aspects of the federated distributed simulation, such as allowing for backup, maintenance, and load balancing of some of the systems. So stop using the simulator because I need to restart it. I'll just transfer the modeling responsibilities to another federate, or half of the units to another federate to do load balancing. And it allows you to transfer only certain attributes or all attributes associated with an object. So the NETN TMR, the Transfer Modeling Responsibility FOM module, provides a standard interface and a protocol for doing this negotiated and coordinated transfer of responsibilities. We also included interactions here, so we can trigger such a event, such a transfer. So we can trigger the transfer modeling responsibilities using interactions based on some event in the simulation or by operator input. This is also based on a service request response pattern. So we're requesting a TMR service or requesting that. And there's an offer saying, well, yes, I can take this responsibility of modeling these units. or vice versa. If I want to take the ownership, I need, of course, to request the possibility to get those units. And then we are using HLA ownership transfer at the end in order to actually move the responsibility of modeling the different attributes. So these are all documented in more detail, of course, on the in the standard itself. But the basic principle is you ask for permission to get something, you negotiate that, and then you receive it. And vice versa, if you ask to relieve it, of course, it's kind of an inverse pattern. So the transfer modeling responsibility pattern is very powerful, and it's also being used or can be used in another quite powerful FOM module for aggregation and disaggregation. So the problem we are trying to address here is that you have a simulation with a representation of, on an aggregate level, units, for instance, a battalion or brigade level simulation. And at one point in time during execution, you want to deaggregate in order to have a higher fidelity representation of what's going on. So you're switching from aggregate level representation to a lower level representation. It could be a lower aggregate level or even platforms, or even a mix of different levels. This is a very old problem, has been tackled in many different research groups in order to provide a good mechanism of doing this. The really hard part is actually to, when you do the aggregation, to place the units at the right location and with the right initialization values. This is not handled by this pattern. This pattern only helps you to initiate and coordinate the activities that needs to be taking place in order to do this. It doesn't help you to do the actual deaggregation. So the pattern itself is just a mechanism to initiate the aggregation or aggregation, and it's a way of providing information to the different modules when it's time to take ownership and responsibility of deaggregated or aggregated units. A short example, and this has been tested in a previous task group as well. You have a simulation representing a number of companies on march on the road, and suddenly there is some event that will trigger the deaggregation of these units, because we are going to model the effects of this IED and the CBRN effects associated with it on a more high fidelity level, on a more deaggregated level. So there is some event that triggers a deaggregation. The two front platoons are deaggregated based on this pattern. We move the responsibility using the TMR pattern to a higher resolution federate that models the effect of the IED on those entities on the lower level. So for instance, in this case, 2 vehicles are destroyed. And then we re-aggregate, and we are maintaining states so that the aggregate unit will know which of the 2 units have been destroyed. The count here is reduced by 2. So we are managing all of those interactions and transactions that needs to take place in order to deaggregate and then re-aggregate the different units. And this is described in the standard, and it's a number of sequence diagrams describing this. We have something that triggers the event, and then disaggregation request is sent to the different federates, so an aggregate federate and disaggregate federate that are involved in this transaction. And you get some response saying, well, I'm willing to do deaggregation. There is potentially a transfer modeling responsibility from the aggregate federate to this service provider. You register the deaggregated entities, so now deaggregation takes place. So instead of representing the company, I'm representing the platforms. These are discovered by some other simulation that operates on the disaggregate level. And it will also respond back on this request saying, I'm willing to take the responsibility of modeling these units at this level. So there will be a negotiated divestiture from the service provider to the high fidelity model, the disaggregate federate. And then the action is complete. This is the deaggregation process. Request deaggregation, take ownership of the aggregate unit, register the platforms on the disaggregate level, give ownership back to the disaggregate federate, and then it's complete. Then you update the disaggregate entities, and then of course you can also update aggregate entities as well. Vice versa, for aggregation or re-aggregation. You send a request, you get a response, and then you start taking back ownership from the disaggregate federate in order to take the ownership of all those platforms. You either delete them as entities in the simulation or deactivate them, and then you transfer the modeling responsibility back of the aggregate unit to the aggregate federate. So that's the process. So that's the aggregation disaggregation or multi-resolution modeling FOM module. It's based on input from primarily the US and the JMRM, the Joint Multi-Resolution Model, which connected JTLS and JCATS for doing aggregation disaggregation in support for Joint Warfare Center in Stavanger. And currently we are not updating this module in version 3, so it's going to be the same module as in version 2. A completely new model or module is the Entity Tasking and Reporting, ETR. It was discovered that there's a requirement for being able to represent tasking entities running and simulated in the CGFs through HLA. So we are being able to send tasking messages to the Federation, referencing units and platforms, which then can be picked up by CGFs and perform those tasks. So it represents lower level tasks suitable for providing information to simulations as instructions to CGFs. And this allows us to interact with not a specific simulation, but with the Federation. So instead of having a GUI sending interactions and controlling CGF units for a specific simulation, we send it through the Federation, and depending on which simulation is responsible for modeling that specific unit, gets that information and can perform that task. So this is based on research by TNO and Norwegian FFI, so TNO in the Netherlands and Norwegian Defense Research Establishment, FFI, in support of simulation C2 activities, also in NATO. And it's now been used to support some exercises to be able to control multiple CGFs through a common simulation GUI. It provides a common interface for sending tasks, but also for reports back from the simulation. The level here we're talking about are simple tasks like move along a route, establish a checkpoint, and things like that. So it's not very high level complex task as you might find in CBML or other standards that expresses different types of orders. So it's a more CGF instructions, if you like, more what you would expect in the user interface of a CGF. But it allows us to control multiple CGFs. It was previously called the low-level BML, but it's been renamed now to ETR. These are some of those tasks that you can find in the standard. So you can do mount, dismount, fire at location, fire at entity, change speeds, establish checkpoints, remove checkpoints, set obstacles and clear obstacles, and things like that. So this represents a core set of tasks that you can provide through that interface to the different CGFs. And the idea here is to provide the most common tasks in order to allow you to build interfaces that will interact with the Federation rather than with the specific simulation. Each simulation, of course, have probably extended set of different tasks that you can access through their own interfaces. But these are the ones that we harmonized on. And it's being used in the Viking exercise in Sweden in 2018. It will be used in experimentation in the modeling simulation as a service task group in NMSG. It will be used for future exercises. It's supported by some tools, some commercial tools as well. So there is some acceptance to this module also by industry to implement support for this. There is also one module that we are not changing now in version 3, which was developed by UK in version 2.0 of the NETN. It's for representation of CBRN, source releases, hazard areas, detectors, effects of CBRN effects, and protective measures. So it's an extension of the ReperFOM that has these types of objects and interactions in order to model CBRN and CBRN effects. It was implemented in 1SEF by the UK and tested in experimentation in previous research task groups. But we are not changing that for version 3. I mentioned before that we are looking at a representation of weather. This is also based on a lot of different input from different standards like SIGI, major federations running in the US and Europe, in order to represent environment conditions associated with either geographical locations, like a region or areas, but also being able to represent weather for a specific entity, like the weather around an aircraft or the weather around an airport. So you can also reference individual entities and describe the weather and other terrain features, weather around the building or weather around the mountain or so. And we are focusing on both the terrain surface weather. We're talking about water surface weather, atmospheric layers, and subsurface volumes of water. So we're trying to address all the domains. Space is not in there right now, but these are the domains that we are addressing. And this is currently being tested in another research task group for dynamic terrain, MSG 156. So we are still getting feedback on this. So it's not been decided to include it or not in the version 3, but it's based on a bunch of input from different federations, and we really want to bring it into version 3, but we'll see if we can complete it in time. We try to make sure that it's possible to support the major CGFs, so we try to balance the FOM module to represent the core attributes and the core ways of representing weather. Also to be able to generate SIGI is an important aspect. Vessel identification and data. This is a very specific FOM module for this domain. So civil ship traffic has a system called AIS, Automated Identification System. So they are sending out their position, information about cargo, destination, ports, nationality, and other information. And there's a need to be able to represent this in simulation to generate these AIS tracks in simulation, and also to stimulate CETO systems with AIS traffic. This has been actually used in real exercises. So we've been using in Sweden a system from TNO in the Netherlands to support exercises where we generate AIS traffic from simulation data. And now we're bringing it into this object model in order to standardize a little bit further on those aspects. But I will not go into detail on this either, but it's important to know that we have these other modules here as well. So before I end my part of the presentation, I just wanted to let you know how do you access this information, what is the copyright and what is the classification level. So as I said before, they are not classified. So not classified allows us to bring it to everybody. The FOM modules themselves are not classified. The associated documentation is not classified. However, the copyright is NATO or TAN, and as I said before, it's the NATO Modeling Simulation Coordination Office is managing the updates, but the NMSG creates these task groups in order to maintain actively to actually do the practical work. There's a license here, so it's a Creative Commons Attribution No Derivatives 4.0 international license. It's free to use, even commercially, so you can use it. It's free to distribute with the attribution. However, you cannot change it without joining one of those task groups. You can extend it with your own FOM modules, FOM module extensions, but to change the actual standard, you have to engage in the NATO activities. To get engaged in actually working actively with updating this, you need to contact your national representative of NMSG and tell them that you're interested in getting access and joining the activity. Currently MSG 163. And where can I find all of this? GitHub. So one of the reasons why we moved to GitHub is that even though we are fairly quick in developing new versions, 4 years, during those 4 years, a lot of things happen outside. If they don't have knowledge what's going on in the NATO standardization work, they will invent their own solutions. So we decided to be more transparent. So there is an area called AMS-B04 on GitHub, and each module has its own repository, and there is also a repository for the entire FOM. And in those repositories, you will find the released version in the master branch, and you will find the latest development version in the development branch. So you can always access the latest version through this webpage. You can see what issues we're working on. You can add your own issues. But if you want to engage and actually submit changes, you need to engage in MSG 163. That was an overview of all the modules, or most of the modules that we have so far. Read the documentation, download, test it, provide feedback. So that's the end of this first section on the NETN FOM modules.
So, thank you all for coming back to the second part of the session. Now that Horst and Björn all made you to experts in the field of HLA and NETN, we want to talk about some hands-on and how we can test systems that have those features, those interoperability features implemented, and even to certify those systems. So first to the background, Horst already mentioned that making a federation, building a federation and making federates interoperable is a very complex and time-consuming task. And for that task, we are relying on standards like the HLA standard, like DIS standard, and so on. And in order to even more improve the efficiency for exercises and for training, we developed a certification tool and a testing tool, which is the IVCT, and that tool might help you or should help you to, in order to go to an exercise, before you go to the exercise, to test your system, to test your configuration, to test even your federate, so that when you show up to the exercise, that this time setting up the exercise will be immensely reduced and will help you to find mistakes in your configuration early instead of using a lot of time in front of the exercise. What is the military relevance? Why is NATO interested in having such a tool, such a certification process in place? Now, I already mentioned that having such a certification or such a tool in place reduces the time for setting up exercises. And if we reduce the time for setting up exercises, we can conduct more exercises. And if we can conduct more exercises, we can increase the force readiness. We have more forces ready in the end. That is one reason. The other reason is, for NATO, it is very important that we are sure that there are no mistakes in the transfer of information between one federate and the other federate. We want to have the whole federation be consistent. And in order to do that, certification helps. If we use certified systems, we are sure that the information is transferred between those systems properly and without mistakes. We always talk about exercises and training. But in fact, NATO not only uses federations for exercises and training, but also for analysis and for mission rehearsal and for wargaming. And here it becomes even more important that the information is transferred properly and without any mistakes between the federates. What is the rationale or the history of the certification process? As you can see, we are not the first group or the first nation who tries to have a certification process in place. Over the course of the last 20 years, there were several different projects, groups working on the certification of HLA or interoperability standards. And you already saw that, and you know from your own experience, that the standards evolved over the time. So when you see the first US efforts for certification, those were only considering the base HLA functionality and certifying those. But now that we have NETN standard, as you saw in the last hour, with several different modules, we also want to make sure that those modules are implemented correctly. What are the use cases for using the certification process? Well, first of all, it can be used as an acceptance tool for the procurement process, so that, for example, Germany is using, was aiming to use the certification process for future procurements of simulation systems, so that only certified systems will be procured for the German Armed Forces in the future. It is, as already mentioned, should be used for preparing federals for training and exercises and other similar events, as I already mentioned, wargaming. And the tool and the certification process also supports the development and the testing of new features. When we talk about the tool and the certification process, we also have to talk about the concept of badges and interoperability requirements. What you can see here on the left-hand side, this little icon here, this is what we call a badge, and a badge consists of different interoperability requirements. Each interoperability requirement describes one particular feature of interoperability feature of a simulation system, as you can see here. And those features can be tested by a tool, the IVCT tool, or that is something that has to be verified by a human in person. So, for example, documentation is available. That is nothing that the tool can test, but this is something that a human has to look at. And a collection of those interoperability requirements is then put together as a badge. And those badges can be based on a particular FOM module. So we can, for example, have a badge for the logistic module, and the interoperability requirements in this logistics badge then list all the requirements that you should have in order to successfully be certified as having this logistic module implemented. It can also be based on a particular behavior. For example, we can look at crisis management, where we not only have one particular FOM module, but something that is based on different FOM modules, like a disaster FOM that is developed by Germany, and together with the CBRN FOM, for example. And then we can have a badge for this. Or we can imagine also a badge for a particular exercise as a preparation, preparation for an exercise, for a particular event, where we want to test our systems before we get to the event, if all those interoperability requirements for this exercise are met or not. Before I go into detail with the certification process itself, I would like to hand over to Reinhard, who will talk about and present a live demonstration of the IVCT.
Yeah, about the tool, or more the framework of the tool and the concept of the tool. The IVCT tool is, in one sentence, an open source software that is able to perform all these tests. It's more like a framework. It's not a ready tool which is closed by now. It's a framework to develop test cases, to extend with the European standards, and finally to be used by the community. Before we started with the tool, we thought about what would be the requirements, what do we want from the tool, and besides some detailed requirements, these are, I think, the most important requirements that we came up with. First of all, it should be an open architecture, open in the sense that it's been transparent what we're doing, how we're doing it. It should be extendable by new test cases, even by new test approaches. Currently, we're using HLA as a standard, but even that would be open. It's just a different test driver. We are using kind of a microservice architecture to separate the different components into small elements that can be replaced. Like, for example, the test engine is a individual component that if you want to move from HLA to this, we would change just this one component, and the rest of the framework would be the same. It is open source. I will come to that in a second. That was a very important design goal from us from the very beginning. The second main requirement was we wanted to support this interoperability concept that Tobias just presented. This is from our point of view the first approach to specify the interoperability requirements that we normally find in the description of a FOM module. All the interoperability patterns that Björn just presented, they are described in text form, but they're not clearly specified as requirements for interoperability behavior patterns. And this concept of the badges, which was, I think, developed by UK, provides a formalism mechanism to specify these and to use this as a groundwork for specifying and selecting the tests for that. Another requirement was we want to have all components ready to be used in a service-oriented architecture. So we decided to use container-based technologies to make the availability and the deployability of these components as easy as possible. When you hear open source tools, many of you might think that, oh, now I have to download a lot of source code, have to compile these things, have to get all the components up and running. We wanted to avoid this. We wanted to pack this in a container, prepare this as a ready software. You just have to get your deployment definition, and then that should be everything you need. And the last point, it's not just for certification. We wanted to have the tool to be available for other things like developing federates. You need to have some kind of a testing environment. If you're tasked with the development of a new interoperability pattern, normally you don't have a sparring partner, you don't have a testing partner. And these test cases could support these kind of test-based developing support. Also, during the integration, you might put together different federates, and if one of these federates are not behaving according to the interoperability specifications, you might use this tool as a monitoring tool to discover if all the patterns currently going on are correctly executed, or if one or another federate is not fulfilling all these interoperability requirements. About the features, this is more the high-level overview about the features of the framework. So starting from the top left side, the organizations that defining these kind of interoperability requirements are, in our understanding, the standards developing organizations, which is, for example, CISO is a good example for that. They're defining the object models, the behavior patterns behind these interoperability requirements, and we think that along with these definitions of the code, they should also define the interoperability requirements they expect from a federate to fulfill, to have a clearly defined requirement to be implementable by the federates, and also to be testable, by the system integrators or by the people buying these federates. Then on the right side, the simulation developer needs to have a kind of a reference point about the standards he needs to implement. And that is the second part, to use the interoperability requirements, to use it as a reference point for implementing certain interoperability requirements. On the bottom, for the interoperability requirements defined by the standard development organizations, you need to have test cases developed. This is I think an ongoing process. Whenever you define a new interoperability pattern, like the patterns presented by Björn, you need also to define the way how these things should be tested. So in my understanding, the communities defining the interoperability requirements would be in a good position also to define test cases, or even maybe implement the test cases. And finally, these test cases, together with the systems, will then be used by the operator of the IVCT tool to select the test cases, select the conformance statements of the tool, and see what tests can be used to prove if the system behaves according to the specification. So coming to the point why we choose to use open source software, let's say the driving point or the higher goal for this kind of software was to make federated simulations more interoperable. So we thought whatever helps to make these resources available or reach this goal should be available without any kind of limitations. We don't want to put any restrictions to get the software or any restrictions to come to the concept of the interoperability requirement. That should be as open as possible, as transparent as possible. all the architecture, the concepts are open and openly documented. And I think open source is a good tool. The concept of open source software is a good way to achieve this. And it's also the development of such an certification tool along with the test cases, I think is a ongoing process. We will not be able to develop the system, let's say, at the end of the year and then it's done. This will be an open tool. It need to be extended whenever new modules are being defined. You need new test cases. You might need to adopt the tool for specific testing environments. As Tobias mentioned, when you use this tool in a procurement setup, you might need to, or you might want to connect this tool to your own procurement mechanisms so you can extend the tool according to your need. And to allow this, we have chosen, let's say, a business-friendly license, the Apache License 2.0, which allows us to use this software without limitations. We can extend it without limitations. You can use it in commercial applications. And you can also combine the license with other license, like if you have test cases which should not be open for whatever reason, maybe specifications are closed or you have a different business case behind that. That's also possible to combine these licenses. The tool is available like the modules on GitHub. That's the screen on the left side. We have a certain number of repositories. The most important for you, if you want to check this out, is probably this one, the ISD operation. That is a definition of the configuration files you need to bring up the tool. It's based on these Docker compositions. What you essentially are doing is you download a script defining the configuration of the versions you have, and you can start this. And the software will be available on Docker Hub. Docker Hub is a repository for containers which can be downloaded from the internet. So all the assets that we have will be built and created as Docker images. So there's nothing you need to compile by yourself. About interoperability test, what do we think is an interoperability test? If you consider a federation manager who wants to combine several federates into one federation used for training, used for decision support systems, and the federation manager wants to make sure that you only include federates which are not destroying a federation, which are not bringing any invalid behavior into the federation. So what you should do, and what you now can do with this framework is you're going to select the interoperability requirements that you want to see from the federate. Like you want to see that these systems is HLA compliant, that's maybe a given. You want to say that all the federates which are included working along the NETN forms, or maybe just selected NETN forms. And then on the other side, the federate owner can express the capability of its simulation systems also based on these requirements. So it can have what we call a conformance statement referring to the batches that he believes he is compliant to. And with these two statements, the performance statement and the requested interoperability requirements, you can create a test to see if the federate really behaves according to all this interoperability pattern. And if that's the case, you can be relatively safe to allow the federate to enter the federation. So that is the principle behind what we expect as an interoperability test. As you know, currently people are working on the next version of the HLA standard, and currently we are discussing about the concept of a trusted federation, so that nowadays you can just connect your federate to any federation and just join the federation. You don't have any technical means to restrict the access to the federation. And the idea here is that with an extension of the API, of the HLA API, you would be able to pass some kind of credentials to the RTI, and the RTI can then decide if these credentials are sufficient to join the federation. And so the idea is we can use the result of a test in the form maybe of a digital certificate proving that the federate has passed a certification test. And this could be used as, This could be used as the credentials passed to the RTI, and the RTI can then decide if it's okay to join the federation or not. As I said, that's currently discussed in the HLA4 PGT, but I'm pretty optimistic that this will be included in the specification. About the tool, I don't want to go into too much detail, but just give you an idea what the IVCT architecture generally looks like. It's actually quite simple. We have here on the green box the federation, including the system under test that we want to examine. The system under test might need other federates for its working to have their federates that interact with the system under test. We might also have other auxiliary services like a geo-information server or any server with maybe a map server. They are combined into one federation, and the IVCT tool will essentially be just one another federate entering this federation. So the test engine running test cases will join the federation. It will run test cases according to the request of the IVCT operator, and will create reporting and documentation of the results. That is the basic concept of the test system. So we have two areas. The green area, this is just the federation as it used to be. We don't change the FOM definitions or anything, just use the existing federation. And the IVCT will only have one component of it, the test engine, as a federate in the system under test federation. Then how does the test case look in detail? So beside the system on test, which is a federate, we have the test case just as a normal federate. It will have to fulfill two interfaces, the one which is connecting to the RTI, and then we have defined an interface to connect the test case to the execution control environment, to start the test case, to get the results from the test case, to get the verdicts, and to control it. And the test engine essentially selects the test cases from a library. This library is organized as test suites and run it in the engine. That's the core principle. And inside the test case can be anything that is required to test a certain behavior. We don't have any restrictions on that. The only restrictions we have is, or the only requirement we have is this abstract test case interface. That is a very quite simple interface that needs to be implemented. And then the test case implementation can be whatever is needed. It could be the state machines following the patterns requested by the FOM modules, or it could be anything else. So, just very quickly about the build environment. It is built as you would expect it from a modern open source implementation environment. You as a user of the tool would be most likely the IVCT operator. You're running the tool in either your own environment or on your own machine or on a cloud machine. Use it via a web-based interface. And on the other side, on the left side, this is the build loop. So whenever the IVCT developers or the test suite developers are releasing a new version of the tool or of the test suites, a continuous integration process will be triggered and will create the updated compositions, which are actually the updated versions of the software. And when the operator or the manager of this tool decides to change the version, the Docker engines will just fetch the new versions and you have it ready. You don't need to be bothered about reinstalling software. So the software release process and distribution process is quite simple. You just need to change the version you want to use. So now the point where I can quickly show you how the tools really look like. Okay, that's the web browser that's used to use the tool. You have to log in, of course, and then the interface is quite simple. You have three different areas here. The first area shows you the badges that is currently being installed in the tool. So what we have is a HLA badge, we have a tutorial badge. Together with the operational badges, we're also supporting a tutorial for the test case developer to demonstrate how the test cases should be created, should be organized, should be defined. We have some extension test cases. These are not complete list of the test cases we have at the moment. The other test cases testing the reckoning, testing certain features of the FOM. And besides, I lost my mouse pointer. Okay. So this is the, let's say, the reference point for the interoperability specifications. Then you have here the test suites. The test suites are the libraries, the containers for test cases. These will be provided by the test case developers, and they look like following. They have a description what they supposed to do. They have test cases included, and they have a list of requirements these test cases are going to test. It's quite straightforward. Then the system and the tests. Just have here a demonstration test here. It has this system on the test has a conformance statement saying which batches it wants to comply to. These are listed here, and then you have a number of test cases you have to pass, and you see in this buttons the test case. And if you want to execute a test case like this one, coming in this window here, if you start a test case, you get a dialogue between the test case essentially and the IVT operator. That's required because some test cases requesting a certain behavior from the system test. Like some test cases need to be in the federation before the system test comes into the federation in order to see the bootstrapping process. Or others require a partner federate to be joined the federation. But this is being explained in this dialogue. And then you can start test case and you see a log file, what the test case is doing. It runs for a specific time. That depends. You can have a test case that runs for a certain time frame, or it runs forever if it's just a monitoring test case. And when it's finished, it gets you the vertical test case, and you have the result of the test case. That's the current state of the tool. As I said, it's currently under development. We plan to release the tool in the final operation capability at the end of the year. I think you will talk about that also. So at the moment it's still in development, but I think it's close to the final release. So my last point here is how do we think you could benefit from the tool? So from the different user perspectives, if you are a provider of a software, if you're developing software, I think that is a way for you to get a quality label, a quality improvement. So if you want to demonstrate and prove that your system is being compliant to what you claim to, this is a way to you to express this. So getting the certificate badges is a label for you to prove that you're passed the test. As a developer, as I said, you will have a framework to develop with new FOM modules without having a running federation already. So it can be your developer-specific test environment. As a user for the tools, you can now see that the tools have passed as a test in order to be a bit more reliable, to be behaving according to the requested interoperability pattern. I think Tobias also mentioned if you're in a position that you are using a federation with a lot of simulation systems and they are interworking somehow, it's almost impossible for you to decide if all the interoperability pattern defined in these modules are correctly executed. If you don't see any obvious inconsistency, it's for you almost impossible to define to test if everything is correct. So that is a way to give a more reliability, credibility for the user. Of course, the customer for the procurement procedures, you now have a way to really test what you expect to buy. The system integrator, as I said, can monitor the behavior of the federates being integrated and can see if one of the other federates is behaving incorrectly. And For the community, I think it's a framework to be accepted by the community, to be extended by the community. It's clear that such a task to provide tests for an interoperability tests for all the patterns that we have is too much for any group that we have. My hope would be that standard developing groups, organizations should adopt these tools, should define, along with their specification of the FOM modules, also the interoperability patterns and requirements that they expect that the federal needs to fulfill. And in best case, also the test cases to actually test these requirements. To use that as a framework available for everybody, they expect to apply these patterns. I think if a developing organization not just provides the specification of the standards, but also the supporting tools to adopt this in the development, again, that will also help to have better acceptance of this FOM modules. That's all from my part.
So now to the last part, we want to talk a little bit about the certification process itself, now that you've seen the tool. And I will make it quick because time is running. The compliance test and certification, for what can it be used? As you can see here, it can be used for single systems as well as for specific configurations, federations, or even federations of federations based on their external interface. And as Reinhard already explained, it can be used by almost everyone who has such a system under his control, his or her control, and wants to verify this executes correctly. For the certification test, we have to talk a little bit about the important key roles here in this system. We have the accreditation authority on the top, which is represented by, or which is currently the MS3, the Modeling Simulation Standard subgroup. We have the certification entity, which is the Modeling Simulation Center of Excellence, the organization I'm coming from. We have test inspectors, which can be anyone who applies to become a test inspector. Currently, it's the members of the Modeling Simulation Group 163, which are presenting today. And we have you, which is the customer. And then we have some roles and tasks for those key roles. The accreditation authority accredits the certification entity and the test inspectors, and not only that, they also accredit the tool, the IVCT tool, and the test cases that are used for the official certification. And the lines you can see here is all that happens before the actual certification test takes place, which is the accreditation and also the customer building its his or her testing environment and already executing a self-test, which we will see in much more detail in the following slides. The second step, represented with the black lines here, is the certification test itself. I will talk about that in a different slide. And the last one is money flow. So, of course, the certification test is not for free in the final operation capability. It is now as long as we are in the initial operation capability, which will probably end by the end of this year. So the idea is that the customer pays for the certification to the certification entity, and the certification entity makes sure that the accredited test inspector also get paid for his or her service. Now let's look at this in detail. This is what the certification or the certificate looks like in the end, with different information about your information, the system under test, and the badges that you acquired during the certification process, and of course some information about the IVC tool. Let's look at the certification process itself in detail. So the certification process starts with the self-test. What is the self-test? So you are the customer and you have a federate that you want to certify to some badges. Then the first thing you have to do is test the thing yourself. So you're building a testing environment at your own facilities. So that means you have a federation, an HLA federation. You might have some auxiliary federates here as well, in order to make sure that the simulation runs correctly. And then you're downloading and installing the IVCT, and you're running the IVCT to make sure that at the actual certification test, everything, your system passes the test. You don't want to pay the accredited test inspector to come to your facility only to see that the IVCT tool finds some mistakes, some errors in your configuration. So you're running the IVCT tool already yourself without any interference with any other key rules or with any money already spent other than working hours. And then you verify that the IVCT or that your system successfully passes the IVCT. At this point, you could stop and say, that's enough for me. I don't want to have a certificate. I only want to verify that my system is properly configured, that the developers did a good job in implementing the standards that I want to use for my next event or exercise. However, if you want to go a step further, you start the certification process. So you already know that at this point that your system will test the certification because you run the IVCT. So you start the certification process by requesting the certification at the certification entity. The certification entity then tasks a test inspector. So if only one test inspector is available, it will test directly. If multiple test inspectors are available, it will send you a list of the test inspectors and you can choose one, or we can recommend one. Then the test inspector will come to your already established testing environment and inspect the testing environment, which means, are you using the right software version? Are you using the accredited test cases? And then you run the IVCT together with the test inspector, and the test inspector then collects the test results, reports back to the certification entity, and the certification entity then will issue the certificate to you. Of course, in the background, there's some contracting between the customer and the certification entity, between the certification entity and the test inspector, so that the money flows also correctly. More information about the certification process and the IVCT you can find on the website from the Modeling Simulation Center of Excellence. And at this point, it was a very quick run through because we are 5 minutes close to the end. Do you have any questions?